This project will focus on sustainability and the use of recycled materials and sustainable strategies on site. Finding ways on site to reuse water, building materials, and sunlight are important aspects of this project. Two examples of the passive strategies used on site are solar panels and an underground cistern. This solar panel diagram helps explain the way energy from the sun can be used and ways this building can benefit the surrounding community with its excess power. The underground cistern diagrams shows the way in which the rainwater will be collected from the building's roof through gutters and downspouts and saved in a tank underground, which can then be reused throughout the site with hoses or in the building for toilets. Bioretention planters and planter boxes are a great way to collect water runoff from either the street or building. The planters are located on site near the parking lot and sidewalks to collect this water. The planter boxes are located at the back of the buildings. These collect water from some of the gutters and help manage the stormwater on site and allow for natural vegetation to grow and filter the water. Since these units run the full depth of the building, by having operable windows on both the back and front allows for natural ventilation in each unit. This axon shows the different sustainability methods that are used on site that were just explained in the previous slides. This helps locate all of those different strategies on the site and the building. This enlarged site plan also calls out other spots on site where these sustainability methods are used. After studying different construction types and the surrounding context of LA, the construction type used for this building is Type 5A, which is wood frame construction. The ductile material flexes and bends when impacted by an earthquake and allows for the use of shear walls and can be bolted to the foundation for extra precautions when thinking about earthquakes. All components of the building's structural aspects along with the MEP aspects interact with each other. Incorporating MEP design at early stages of projects can reduce the risk of major issues arising later in the field. Each unit, along with the community room, has its own MEP closet, which consists of electrical panels, water heater, HVAC equipment, and anything else relating to this space. To save space in multifamily residential units, sometimes these rooms are shared with laundry rooms or closets or other storage rooms. Benefits of stacking plumbing walls include saving money, less piping, and potentially can eliminate roof penetrations. Shear walls help resist lateral forces caused by an earthquake or high winds. All forces, as shown in the diagram, are working in unison with each other at all times to remain structurally stable. All exterior walls are load-bearing walls. Other bearing walls are shown in this diagram in the pink highlight. This matrix looks at all of the important building information, including construction type, the square footage of each of the units and spaces, the means of egress, width, and then kind of the occupant load and other important information. This wall section looks at all of the components, including floors, foundation, exterior walls, and roof. Each specific part plays a crucial role in the building structure. Allowing for clear paths of exit in an emergency situation was considered carefully. As mentioned before, the units are running the full depth of the building, which allows for more natural light, windows, and natural ventilation. The units were designed strategically and thoughtfully to allow for both form and function. Stacking plumbing walls and providing a closet or space for MEP is important to think about when designing a building with units. There is much coordination that needs to be considered. As seen in the matrix, in this case, there needs to be one Type A or accessible unit in the building. This unit is located on ground level with a clear egress path that connects directly to an exterior accessible path. The unit needs to take into account counter heights, hall widths, clearance zones, workspaces, turning circles, and many other components. The precedent project helped view the proposed project from a couple different viewpoints. This precedent project is similar to the proposed project in the way that there's very minimal corridor space. In the proposed project, there is only a common stairway. The site, community room, and spaces that the site helps create is where residents will engage with each other and the surrounding environment. The elevated deck allows for moments of vegetation to grow, similar to a bioretention planter. This passive strategy used to help manage stormwater on site and connect residents to nature in a rather industrial location. This precedent building is located in an industrial neighborhood, which is similar to the proposed project. By creating different moments with color or geometry changes in the architecture, it connects residents to the building in a more unique way. Similar to the proposed project, these unit stacks allow for plenty of natural light with windows on both the front and back, which allow for natural ventilation. These unit plans focus on stacking plumbing walls in a similar way as the proposed project does. By stacking plumbing walls, it saves money, requires less piping, and potentially eliminates roof penetrations, as I mentioned before. The building sections help emphasize the angled roof. The angled roof allows for water runoff to be collected at the rear and reused on site or in the buildings. These sections also show the relationship of the units to each other and how they're stacking. The building uses recycled metal panels, which is a nod to the surrounding industrial context. There's Energy Star operable windows, solar panels, and many more design features as mentioned before. The low-rise look of these buildings also helps connect the surrounding industrial site context, along with the other low-rise residential buildings located planned northeast of the site. The site was divided into 5 different spaces, one being a shared common space that acts as a passageway for pedestrians to connect to the site, and industrial neighborhood to the park, located just below the Whittier Boulevard Bridge. This section helps shows the relation of the existing warehouse industrial building located planned west of the site and also to the Whittier Bridge.